Hello, my name is XiaoWang, and this is my demonstration video for the wireless communication project. The title of my project is The Combination Advantages of MIMO, which is Multiple Input, Multiple Output Technology, and OFDM. The first part is about the introduction of this project, which aims to study on the combination advantage of MIMO-OFDM through simulating and outcomes analyzing. Basically, there are two parts in this project. The first one is a comparison among different wireless communication schemes, such as single input, single output, multiple input, single output, single input, multiple output, and also multiple input, multiple output. And there are also simulations for MIMO-OFDM when adopting different modulation or demodulation approaches. I try to evaluate the applicability of MIMO-OFDM in different communication systems. So this is basically the purpose of this project. And there are problems under this study. In the modern communication environments, spectrum distribution is hard to modify by users on specific frequency band because spectral distribution is usually ruled by the government. So we cannot easily to increase the bandwidth of the channel to increase the channel capacity. And also with Shannon-Hartley theorem, the channel capacity value is related to the bandwidth. And on the other hand, accompanied with the development of digital transmission technology, demands on higher data rate keep rising. And moreover, problems caused by multipass effect, which is basically risen by the MIMO technology, is considerable on wireless communication. As you can see the figure shown on the corner, this is basically the scheme of multiple effect. And this is caused by reflection or other issues happening during transmission. Two signals with different phases can suffer from each other, and the received signal can be attenuated. So now, why I choose MIMO-OFDM? So in this technology, it deploys multiple antennas at both the source side and the destination side for wireless communication. And compared to other schemes like SISO or MISO, MIMO can lead to linear increase for the system capacity and the spectral efficiency. And the third reason is OFDM provides solution for the problem caused by multiple effect. So when we choosing MIMO technology, the multipass effect cannot be easily solved. So here is OFDM. In this technology, there is cyclic prefix, which is also shown by the figure on the corner. It provides a guard interval to eliminate inter-symbol interference from the previous symbol. It repeats the end of the symbol, so the linear convolution of a frequency-selective multipass channel can be modeled as circular convolution, which in turn may transform to the frequency domain via a discrete Fourier transform. In fact, for MIMO-OFDM, there are some existing approaches, and I find two examples which play pretty important roles on this field. The first one is about a study on channel estimation of MIMO-OFDM. The proposed method can achieve an accurate channel estimation, which is very important for the performance evaluation of technology. And the estimation in MIMO-OFDM system can be achieved with no or insufficient cyclic prefixes, thereby potentially increasing channel utilization. And the second one is about a study on the impact of intercarrier interference on MIMO-OFDM. ICI, the short way to say intercarrier interference is taken into consideration to enrich the simulating scenario and make it more close to the real-world environment. And after studying on these existing approaches, I summarize their strengths and weaknesses. So for the strengths part, no matter what wireless communication schemes involving SIMO, MISO, and MIMO, this estimation can be widely exploited. And the second one, application of the channel estimation in MIMO-OFDM system can be implemented with no or insufficient cyclic prefixes, which makes the complexity of design decreases much. And the third one, more factors are taken into consideration to enrich the simulating environment, which makes the design is more practical in the real world. And also, there exists some limitation of the existing approaches, like estimations under estimation used for other modulation or demodulation methods are not taken into full consideration. Mostly, they only use BPSK or QPSK to do the simulating. They can also add differential BPSK or QPSK or even QAM to the testing part. I think by doing this, they can make the level of applicability of their simulating more creative and more practical. Before the conclusion part, I would like to show the demonstration of my program. So basically, I do this program by MATLAB and some functions supported by the MathWorks. And the first program here is called test for MISO, for MIMO or other communication schemes. So basically, there are four various communication schemes, like what I said before: single input, single output, single input, multiple output, multiple input, and single output, and also multiple input, multiple output. Let's run this program. So this figure here shows basically with the same single to noise ratio, the channel capacity of multiple input and multiple output technology get the most dramatically increasing tendency, which is very important in the wireless communication. And this program is about I tried a MIMO-OFDM simulating over AWG-N channel, which is basically the common used communication channel with noise adding inside. Let's run this program. It will take a little bit time. Okay, sorry for the waiting time. And from this figure, all curves show the tendency that the bit area rate decreases accompanying with the increasing signal to noise ratio for all different modulating and demodulating approaches. In other words, the accuracy level gets higher when the signal power becomes stronger. Furthermore, the curves of QPSK the right curve, and the differential BPSK, the purple one, basically appear similar trend as the highest modulation efficiency, since their BER decreases the most dramatically with the improvement of SNR. The outcomes can help us make the best option when choosing a specific modulation or demodulation approach for MIMO-OFDM. Okay, so the last program is about the MIMO-OFDM simulating over relay feeding channel, which is another common used channel model in wireless communication. These programs running will take will take longer time. So I have run this program already and get this figure here. And from this figure, all curves appear more complex trend when comparing to the situation over an AWGN channel, but still show similar decreasing tendency for BER with the increasing SNR. This situation shows the modulation efficiency varies with the channel as the result varies when compared to that of the AWGN channel. Moreover, the curve of BPSK appears the highest modulation efficiency, and in the aspect of several QAM modulation schemes, they also appear relatively high performance of the modulation efficiency, which proves the advantages of QAM are reasonable theoretically. And basically, there are the programs and the results from them. And here come back to the conclusion part. So as what I aimed at in this project, the combination advantages of MIMO and OFDM are obvious from several parts. The first one, MIMO improves the channel capacity without altering the frequency distribution. The second, multipass effect resulted from MIMO can be solved by OFDM with cyclic prefixes, which is an important reason of the combination of MIMO and OFDM. And third one, the MIMO-OFDM can be applied into various modulation and demodulation approaches. The third one, more research related to MIMO-OFDM system is rising. Thanks for watching this demonstration video.